In this video, I will explain you three things. The first of all, what is a free fall motion? The second point is how to find the time taken by a ball to reach the maximum height. And the third, last but not least, we will draw all of the graph corresponding to this motion. So let's start from the free fall motion. Let's say this is the surface of Earth and we assume that there's a no air resistance. Then if this object is falling, then it will fall under the action of only one force, that is the force of gravity. Not only that, if you throw this object upward one dimensionally, means that if you throw the object vertically upward or if you throw this object at some angle, in all of these scenarios there will be only one force exerted on it. Not only this example, but also this is an orbiting satellite and this is some its tangential velocity. So even in its orbit in the space, we know that there will be only one force, that will be force of gravity. Okay, now due to this force of gravity, all of these objects whom I have given you example, all of these objects always move with the same acceleration, that is due to gravity, is negative 9.8 meter per second square. This is called free fall motion. And today I'm going to discuss one dimensional motion. So let's start. So if you throw this ball vertically upward with some initial velocity, in the absence of air resistance, how it will move? So it will go vertically up, and as it is moving up, its velocity will decrease, and at some point, at some height, its velocity will become zero. So in every next interval, what is happening? Its distance covered is decreasing. So this is a final position if you want to find the time to reach maximum height. So at this time, we will suppose this the velocity at this point, the final velocity is zero. And if you want to find out the time, then the most suitable equation that we can apply is this one. So v is equals to u plus at, as it's a uniformly accelerated motion. So now we can write this equation for our free fall motion, so it can be written as minus gt. So what is a final velocity? That is zero at a maximum height, and then you can take u on the other side, so it will be negative u is equals to negative gt. So this is a time that is taken to reach maximum height, and that will be the same time taken by the ball to return from that position to the ground, because acceleration is constant, so it will take same time. Motion is uniform. So if we draw its graph, so let's start from velocity time graph. Why? Because if you focus on this equation, v is equals to u plus at, so when we put the value of acceleration negative gt, so after every 1 second or after every uniform or regular intervals, you can see this gt is a factor that is continuously subtracted from u, which means that we will get a straight line graph, but that will be the decreasing velocity. So it means that we can draw the graph like this, because that's a uniform decline in the values of the velocity. So with what velocity you have thrown, that was u. This is a time when it reached the maximum height, and we have calculated that is t is equals to u over g, and that will be the same time if you take at this point. So this is a time 2u over g for this one dimensional motion when it has hit the ground. Okay. Now we are going to draw the displacement time graph, or you can also say position time graph, how the position was changing. So you can see in every next regular interval, the displacement covered is decreasing. So if you focus on this part of the graph, so we see that the velocity is positive, but that is decreasing. And we must remind that the velocity is, isn't it, gradient of the displacement time graph. So if it's a gradient of displacement time graph, means that rise over run. So that means if the velocity is decreasing, it means we must draw such a curved graph. because only curved graph will give you the decreasing velocity. Okay, so we must draw this kind of graph, and at this point the graph must be flat. Okay, because if you draw the tangent at this point, so your tangent line must be horizontal, giving you the evidence that the velocity at this point is 0, and this is a u over g. And you can test. Just for instance, I'm taking the 2 points on this curve, so you can see how the gradient is changing. So if I draw a tangent line at this point, so you see it is a steepest line, whereas the tangent line at this point has a less steep, which means less velocity. Now you must have very good idea that we will have the next part of the graph should be like this, which means that it is now velocity is increasing, because if you draw the tangent on this part, so you will see that the gradient is increasing but negatively, and that's exactly what happens. Velocity will increase at this point, students. It will have a same velocity, but the direction will be opposite, right? So this is a negative value of velocity. And what about acceleration? We have already discussed that it's a free fall motion, so acceleration due to gravity is constant. So, but that is a negative value because that's always directed downward. So, acceleration graph must be like this, which shows us a negative g, a constant value.